Okay, give me a minute. I'll share my screen. Yeah. So welcome all. My name is Mandar and I'm your PyTest course instructor. Before we begin, let's discuss something about myself. I have about 30 years of experience in the IT industry now. I started my career as a C++ and MFC developer back in 1996. And then I moved to the SDET role in 2002. Currently, I worked with different technology stacks. Currently, I'm involved into Python and PyTest as the tools in my daily activities in the in my QA role or the SDET role. So welcome again, everyone. So for this demo course, we'll be touch basing upon PyTest, what is PyTest, and everything about it. Initially, we'll see some slides, we'll learn some theory, and then we'll directly jump onto the coding part of it. Okay. So what is PyTest? If anyone doesn't know it, then this slide is for them. It is a Python-based testing framework. It was originally created for unit testing, but now looking at the power of PyTest and looking at the features and looking at all the kind of use cases that PyTest has been through, it is now used for integration test, functional test, end-to-end test, you name any test and it is used for it. It has a rich set of features, which we'll look into it later on. And it has a lot of support from the community also. So it is used widely for all types of functional integration and all kinds of test activities. So this is not an exhaustive list of features per se, but this is an indicative list of features that PyTest supports. Okay. It is not, I will not dwell upon every feature in detail in this course today because it's a demo course, but we'll mainly focus on the parameterization of the test. That is the feature that we'll focus today. But as the course moves ahead, every single feature that PyTest supports, which is a major feature and which is more popular amongst the testing SDET community, I'll cover them all in the course. Okay, so the first is auto discovery, which means how PyTest will discover your test cases in your domain, in your project or in your product code base that relates to that. The second powerful feature is in PyTest, there is no complicated syntax. It is all Python going ahead. So like you write your Python programs, you write PyTest test cases, only with the difference that each test case needs to have the word, each test case name needs to have a word test in it. I'll explain that as we go ahead. Okay. So you need not worry about things that you can't grasp immediately. They'll become very clear as we go ahead in the demo lecture. And feel free to stop me in between for any test, any questions that you have. Just interrupt me in between. I'm not able to see the meeting screen because I'm sharing. So just stop me by unmuting yourself and ask me any question. That is always welcome. We need to keep this session very interactive. The third powerful feature is PyTest supports a lot of command line options. So what it means is integration of the last part, the integration of CI/CD systems can be done very easily using these command line options. Okay. The next is parameterization of tests, which we'll cover today. As I said, parameterization means it is essentially nothing but data-driven testing, eliminating the need to really, have repeated code for every single data set that you want to test. And we'll look at similar such example today. Though the example is trivial that we'll look, the example is very powerful and it points to the parameterization feature of PyTest very well. We are going to eliminate all complexities other than PyTest in this course. So our examples will be very simple ones, but they will nevertheless teach you everything that you need to know. The next is fixtures. Fixtures is also a very important feature of PyTest, which takes care of lot of functional aspects of PyTest before, after, or during the test case executions. So those who have come from the Java background and know JUnit, they must be knowing setup and tear down, right? So setup and tear down is nothing but called as kind of fixtures in PyTest. You can create a fixture that sets up data for you, sets up email configurations or database connections, executes the test, and then cleans up the setup part of it. So that's called fixtures. Hooks, next one, is a very advanced feature. It is also used for setup and tear down, but on the framework level, not on the product under test level. Like, fixtures will be more into the functional behavior of the product under test or the system under test, and hooks will be more at the framework level. Like, for example, you want to know how many test cases failed out of how much were executed. Then, and you want to know that in a programmatic manner, for any report generation or any Jenkins or any TeamCity related, CI/CD related functionality, then you can always use hooks. Okay. Hooks is again a very powerful feature. We'll look at a few hooks that are available in PyTest. The next one is markers. Markers is nothing but, if you want to have a different name for markers, then you can always say that markers are nothing but tags. You can group tests based on their priority, based on their severity, or based on their nature, like integration or unit or functional or Selenium or API or those kind of tests. You can add any marker that you want. They are called custom markers. You can delete any markers, and based on markers you can group your test cases. We'll see that all further in the course. Second last feature, important feature that we're going to see is plugins. Plugins is mainly to extend the functionality of PyTest. So it is kind of for advanced developers of PyTest who want to add new features to the PyTest framework. So plugins is for them. So one such example is, in PyTest initially there was not a feature to run test cases parallelly, but some good guys, some good developers wrote a plugin called XDIST, and that plugin can now be used to run test cases in parallel manner. Or there is also a plugin for behavior driven testing in PyTest. So that's a plugin. It's not supported natively by PyTest, but you need to, install that plugin, enable that plugin, and then use that plugin to really extend the functionality of PyTest towards the BDD areas. And last important feature that we'll see or we'll cover in the entire course is the comprehensive reporting. You can generate automatic reports of pass, fail, and all those parameters, and push them to Grafana, also push them to Jenkins and everything. So that we are going to check on that. So anyone having any questions so far based on what we have covered till now? Any questions on the agenda? Any questions on nothing is clear or something like that? Please let me know. Otherwise, we'll move ahead. Okay, so no questions. So I'm assuming everyone is in sync with me. So let's move ahead with the next slide. Now, the assumptions for this course are that we will have Python 3.8 plus installed. The computer has PyTest installed, and the audience is well acquainted with basics of Python syntax. No advanced knowledge is needed, but you should be able to at least write Python functions. You should be able to know what is a list, what is a tuple, what is how to write native data types in Python, how to concatenate strings and all that stuff, and use some Python libraries internally in the PyTest and Python code that you'll be writing. So that is the assumption that I'm going to make in this course, that you'll have these things ready with you. Now coming back to our course, what is a test case really? What is an automated test case? So any automated test case we can break up into 4 steps. The first step is arrange, which is kind of setups or prepares the system or product under the test. Like for example, if you want to test an API, then the setup or the arrange phase would mean initializing the endpoint, initializing the payload if it's a post call, initializing the server or something like that, or if it's a database test, then you need to have the setting up of connection string in the arrange phase, setting up of connection string, connecting to the database and returning a database handle. That can be a part of an arrange phase. The next phase is called act, which is your test code, which does the action on the system under test. So like, for example, again, taking the example of the post API test case, if the act phase is now, in the act phase, you can hit the post call with the correct payload and the correct endpoint. Or if it's a database test case, then you can run an SQL query on the database using the database handle that you did in the arrange step. Okay, so that is the act phase. The next phase in the any test case is called assert. So it is a piece of code in your test case which will, assert that the function that you have called in the act phase has behaved really in the manner that is expected to behave. For example, if the post call is expected to return 200 OK, then you should assert that it's 200 OK. If the database API call, if the database test call, is expected to return you a data set, result set of get select query, then it should have the assert statement which asserts on the length of the data set or the field that you are going to get from the select query, so on and so forth. And the last and an important step that every test case needs to have is called cleanup. So, whatever changes your test is doing to the system or the product under test, that needs to be cleaned up. That needs to be, removed from the system and system restored to its original state. So that's called a cleanup, or sometimes some people call it tear down. Arrange is also called setup. Cleanup is also called tear down. Okay, so any test case, any automated test case will have these 4 main elements, and that's very essential to a test case. If your test case is lacking any of these, then it's a bad design. It's a bad coding practice, that is for sure. Okay, so let's move on. Yeah, now the feature that I promised we'll cover in this today's demo is called parameterization. Okay. What is parameterization? So parameterization is a feature which is designed to avoid repetition of test code. So let's say, for example, you are trying to create users, okay, in a system, and you have, let's say, the job of creating 10 million users to simulate some load on some SaaS product. So 10 million users you want to create. You are writing a for loop, or maybe you are doing some parallel processing in Python or something like that. But then the code which hits the create user functionality is the same all across. No matter whether you want to create users called as employees or managers or admin staff or clerical staff or housekeeping staff or account staff, no matter what the type of the user is, it's always create user call. Okay, so what I'm trying to stress here is the create user functionality or the create user code in your product or the system under test is going to remain the same for all different kinds of data. And so naturally your test also remains the same. You don't want to do a different test for testing how to create a manager, and then a different test for testing how to create a junior, or how to create an intern, or how to create a senior, or how to create an architect. That's not needed. We'll see all these things practically, of course, but I'm trying to just point you to some theory before we jump into the coding. Okay, so parameterization helps avoid repetition of test code in the sense that for any given test case, PyTest will automatically run that test case for all the data set, all the rows in the data set that you give to it. And this is nothing but called parameterization. Okay, so let's see an example here. For those who are familiar with UI testing, Selenium testing, what I mean, this is a very classic example. So let's say you want to run a test case and then you have to do a cross-browser testing. Okay, you want to run the test case for Chrome as well as Firefox. Now, don't worry about all this Python syntax on the screen in front of you. It will become clear as the course progresses. But for now, fix your attention on this fixture and is use fixture kind of functionality. So you have been given parameters like Chrome and Firefox, and they run this code. The same code will be run for Chrome as well as Firefox. That's the essence that I'm trying to point you all to. Okay, so now let's come to some code. So here I have created a very simple program called calculator.py, and it exposes a function called add, and it takes two numbers. Addition, of course, take two numbers. Forget the errors here. These are all pylint errors. That is the syntactical errors. They are not compiler errors. So this add function, which I have written on line number 1, will take. Let me move the terminal. Okay. So this function add that I have written on the line number 1 will take two numbers and will return the addition of the two numbers as the result. Okay. So that's the job of the calculator essentially, right? It adds, subtract, multiplies, and divides numbers. So, okay, so that's a simplistic calculator product that let's say we have, and this is the product under test. Okay, now, as I said in the first few slides, the test discovery that PyTest does, that is the way PyTest identifies test cases in your project, is by scanning the name of the test case. So if the name of the test case contains test, see this TEST, anywhere in the file name or anywhere in the test case name, then PyTest will automatically identify it as a test case and mark it for execution. Now, whether it will execute it depends on other factors, whether you have asked to select it, asked to execute it, whether you have selected it, whether you have marked it for execution, so on and so forth. That's another topic. But test discovery means the test cases file as well as the test cases inside the test case file should have the word test in the names of them. Okay, so that's test discovery. So what I've written here on line number 1 to line number 13 is a simple test case that tests the add functionality. Okay, so this is the calculator function which adds two numbers, and this is the test underscore calculator which tests these two numbers. And now I have used an annotation, or in Java it is called annotation, but in Python it is called a decorator. So forget the complex terminologies, you'll get it to know in the course. But essentially just remember that line number 11, this line which I'm selecting, this is a decorator for the test case, and decorator means it adds some value added functionality to the test case. And because we are seeing the parameterization part here, I'm using the parameterized decorator over here, the pytest.mark.parameterized decorator over here, or annotation over here, to mark this test case to be executed multiple number of times, each for this data set. So instead of just looking at theory, we'll just now see how it looks like when you execute. So for execution of the test case, you need to just say PyTest -v and the test file name. If I press enter, it will now show you 4 test cases results. Okay, I'll just maximize it. Okay, so test case, it has collected 4 items. Okay, it has collected 4 items. PyTest Collected means it has discovered that it has 4 test cases. I'll tell you how just in a minute. And it has passed 3 of them and has failed 1 of them. And this failure is a purposeful failure that I have triggered inside it, because I want to explain you some things. And why it has failed, it is showing that assertion failed because assert 10 is not equal to 9. The expected result is 9, but the given result is 10. That's why it's failed. And it is printing the message here, addition is incorrect. Okay, so that is how PyTest looks like when executed. Now let's go back to the test case and understand how parameterization has worked here. Okay, I'll just slightly reduce it. Okay, so now the actual test case is line number 12 and 13. That's all. I'll just select it. This is our test case. So let's check the test case in the context of the anatomy that I told you. Okay, here. In the anatomy context that I told you. Okay, arrange, act, assert, and clean up. Okay, now because it's a simplistic test case, the arrange part of it is taken care automatically here, because we don't have any, we are not introducing any database or API complexities in our learning modules right now. So we have just initialized the test data in a list. So if any one of you has any Python exposure, then you know that this square bracket from here is a Python list. And what is list content? It's a list of tuples. So this individual bracket is a tuple, and there are 4 such tuples in this list. So this test data is list of 4 tuples. Okay, so this is the arrange phase. Now, act phase is when you have, wait a minute. Act phase is when you have where is my mouse? Yeah, act phase is when you when you act on the system under test. Now, what is our system under test? System under test is calculator, and we have to do an add function call. So what I'm doing is I'm calling the add function call with parameters A and B, and I'm asserting as a third step of the test case that addition of A and B should be able to be equal to the expected value. Now, if you pay attention closely to the output of PyTest, you'll see that there are 4 instances of the same test case that have been executed. Test add 1, 2, 3, test add 0.5, 0.7, 1.2, test add these 3 strings, and test add 559. So these parameters 1, 2, 3 and 0.5, 0.7, 1.2 are coming from here. So for when PyTest encounters this parameterized keyword and this syntax of the parameterized keyword inside it, okay, it understands that this test add test case is needed to be run 4 times, or it needed to be run for the length of the list that many times. What is the length of the list? It is 4 because it has 4 tuples. And what is the structure of the tuple? Structure of the tuple is 1 is A, 2 is B, and 3 is expected. Okay, we have told PyTest that parameterize will expect a tuple in quotes with 3 values inside it. Okay, and so we are passing 3 values inside the tuple, one with input 1, that is A, input 2, that is B, and expected value of the test of the system under test, that is expected value is 3. Okay, and we are passing this test data to this parameterize. So internally, PyTest will generate these 4 test cases based on a single code block. That is called parameterization essentially. So what it would do is it will pick up 1, 2, 3 as first tuple, pass 1 for A, pass 2 for B, and expect that the addition will be 3. Similarly, for the second tuple, it will pass 0.5, it will pass 0.7 to A and B, and expect that the result is 1.2. Third is a string. It will expect A as Mandar. It will expect B as teacher, and it will expect expected variable to be carrying the word Mandar teacher, a concatenation of two strings. Fourth tuple is input is A, that is 5. Input B is 5 again, and expected is 9, which is wrong because 5 plus 5 is 10. And that's why the test case has failed here. Okay. So what I've demonstrated here is the nature of the powerful feature of parameterization. Now, if you notice that only in the case of failed test cases is this string printed. See this. In case of pass, in case of past, in case of past, in case of past, there is nothing printed for the extra printed for the PyTest output. And that is the nature of PyTest. You can, of course, increase the verbosity of this. You can add your own functionality. You can print everything that you want. We'll see in the course, in the due course of time. But for now, understand this, that PyTest comes from a Python background, Python community people, a mindset where verbosity is, considered a bad thing. I mean, bad in the sense it just clutters your screen. So if it is clean and minimalistically printed, then it is good. That is what they assume. So in this assert code on line number 13, this message that addition is incorrect. Sorry, this message that addition is incorrect will be printed only in case of failed assertions. That's what I want to point you to. Okay, now, yeah, 4 test cases. Now let's go back to our calculator. Let's add one more function called subtract. Again, we'll say x1, x2. That is 2 numbers. You can give any variable names that you want. And you say return x1 minus x2. Okay, that's the nature of subtraction, right? We save this file. We go back to test calculator. We say again def, that is the keyword. The keyword that identifies a Python function is called def. We say test. And we again say C, D. I'm purposely giving these variable names very different than ABCD. You can as well give AB expected over here. That is not a problem. But in order not to confuse you guys, I'm going to give its different variable names. And this is expected again. We put a colon here, that's the syntax. Then we say assert, we call the system under test. Pass it C, D, and we then, assert that it should be equal to expected. Okay. And then we put a message saying that subtraction is incorrect. The assertion has failed. What is the spelling typo? Okay, in place. Okay. Now, if you notice over here, my subtract call has been underlined as red. That is because it doesn't know where this comes from. So what we need to do is we just have to add an import statement. Go off. So from calculator, import this functionality. That's a Python syntax. We'll see that in the course. But for now, understand that we have just imported. So it's like, importing jars and everything in the Java world. So that's what I'm really coming to. Okay. So now we wrote the test subtract function. Okay. Now we'll run it. But before running it, we'll give it some data. So we will just copy this PyTest parameterize, Control C, Control B. Okay, and now here we have to change because our variables are C and D. C, D, and expected and test data. Let's say we have. Okay, let's pass the same data. How does it matter? Okay, let's see what happens. We'll pass the same data. I'm clearing the screen. Okay, I'll just say PyTest -p test calculator.py. Okay, so it has given me some big errors. Okay, so let's see what is the error one by one. And all the test cases have failed. Addition is incorrect and everything has failed. So we'll just what we'll do is we'll just reduce the complexity. We'll just copy this test data. We'll control C here. One, two. We'll remove this string because that is the main cause of error. If you want to know the reason, you can't subtract strings really in Python. That is here. And then you can put test data 2 here. Sorry, test data. And this is test data 1. Okay, so this test data 1 is the list for the add, and this is test data 2, that is list for subtract. Okay, so let's see. Just run the subtract test case for now. Let's see what happens. Okay, so it has executed the test cases and all 3 have failed. So the reason why they have failed is obvious, because see, this subtraction of 1 and 2 is not equal to 3. Subtraction of 0.5 and 0.7 is not equal to 1.2. Subtraction of 5 and 5 is not equal to 9. So what we'll do is we'll just 1 minus 2 is minus 1. 0.5 minus 0.7 is minus 0.2. Sorry, mouse. 5 minus 5 is 0. Yes. Now let's see if they pass. Okay. Subtraction is incorrect. So 1.99, 0.99. Okay, I think I made a mistake by using the float types here. Let's remove this example. We'll put if, 3. Okay, so that's an easy way to understand. Let's not get into the nitty-gritty details of Python here. Okay. Okay, so now all the 3 test cases have passed for subtract. So what we have done is we have added another parameterized test cases for the test case for the subtract functionality that we have added to the calculator function, calculator product that we are testing. Okay, so now coming back to the test case, yeah, here. Now let's understand it better. What is this at pytest.mark.parameterize? So as I said before, this is nothing but called as an annotation in Java world, or it's a decorator in the Python world. Internally, what happens is when Python encounter, by the way, this at pytest.mark.parameterize, though it is a PyTest parameterization facility that we have added here, this is not something which is supported. This is not something which is only supported by PyTest. Okay, you can as well write your own decorator. You know, for example, I want to say def test divide something pass something, and then you can write your own decorator here, my decorator. Okay, you're here. So I'm not saying that this is a PyTest feature, PyTest requirement, but PyTest parameterization is designed to use the Python decorators. That's why it is in this syntactical manner. Okay, so what internally happens is that when Python interpreter or compiler looks at this test case, before passing the test case to this to PyTest, Python will invoke the parameterized decorator internally. It will pass the parameters, that is C and D, and expected to this test subtract, and then it will call the PyTest to execute for a single test case. And that's why you see this test case is running here 3 times, because every single test instance is corresponding to a single row in the data set. That's how this decorator works. Okay, so that's about parameterization. What? Yeah. Okay, and the last phase that we have is cleanup. Okay, but incidentally, in our test case, in our example, we don't need to do any cleanup. But if we were to have any cleanup, then let's say we were say def what should we say, test was database test check. That is the test case that we have something and pass. Let's say, okay, and then we have parameterization here. Cleanup here added to it. So what will it do is it will execute the test case and then invoke the cleanup annotation, cleanup decorator, and remove the database connection, close the database connection, remove the handle, and everything it will do. So in our example, we didn't have any cleanup related opportunity. That's why it's not seen, but we'll see what teardown, what cleanup looks like in future lectures when we go in detail with Python and PyTest. Okay, so this is one more feature. One more thing I wanted to show you all is, just give me a minute. I am going to show you how to add your own test case names to the parameterized test cases. So let's see what is the syntax for that. So if you go here, it will be different option for test IDs. Yeah. So if we copy this line, we go back to PyTest. If you add here, let's say we'll add IDs only for the subtract test case, and then we can give IDs here. T1. We have 4 rows, right? So we need 4 IDs. T2. The example contained only 1. We have 4 rows in our list test data, so we have 4 IDs here, and then we have T5. Let's say these are the 5 test cases. So now let's see the change. See here, you'll see the change in this naming convention of the subtract test case. Okay, so let's see. Let's run. Let's see if it works. I'll just clear the screen. Oh, sorry. The subtract has only 3 rows in it. 1, 2, and 3. I've given 4 IDs. So we'll remove 1 and we'll change this to 3. See if this works now. Okay, so let's see this. In spite of the data set containing, I'll just reduce this a bit. So this data set on the line number 16, 17, and 18 contain 3 data tuples, but now the test subtract has come up with a new name, and that is coming from here. This parameterization identification, that is what is called specifying IDs to parameters, is extremely helpful when you are creating large number of test cases with varied data in it. Let's say, for example, as I gave you at the start of the lecture, right? If you want to create 10 million users of different types, you don't want to have the user data here in this particular brackets or here. So you can just say for every data row that is going here, you can just specify the name as say manager, or say employee, or say intern, or say architect, and then it will be saying test user in brackets architect, test user in brackets employee, test user in brackets manager. So it's very handy when it comes to identification from the reports, for a large set of test cases that you may want to write. So essentially, that is what I wanted to cover in this demo class today. That is add and subtract functionality and the parameterized test cases for add and subtract. Let's open up for any questions that you guys may have. I'm opening up for questions. Let's make it interactive. Any question that you want to ask, you can ask. Feel free to criticize, admire, suggest, comment, anything that you want to do. I'll be happy to take your feedback. Happy to answer your questions. It will help me learn more and deliver better more. So let's open up for questions.
What is the IDE you're using?
Yeah, good question. So I'll in the actual course I'll be telling you how to install and what IDs that IDE I am using. But currently I'm using PyCharm. So this is it. Wait a minute. It's a newer version. Even I forgot how. Yeah, here it is. Okay. So it's PyCharm Community Edition, and it's available on the JetBrains website. It is absolutely free of cost. There is no money to be paid. But remember, always use the community edition. That's the only edition that is free. You need not use the paid ones unless you have money to buy the license, but it's very costly. Otherwise, you can use Visual Studio Code or any editor of your choice. But
IntelliJ?
IntelliJ is for Java, and IntelliJ and PyCharm are coming from the same vendor. So IntelliJ is written by JetBrains for Java, and PyCharm is written by JetBrains for Python.
Okay.
Yeah. So it's the same company. You're right. IntelliJ and PyCharm both belong to the same company.
But I did see some options for Python also in IntelliJ in the latest version. So I was just
They
curious.
might be having, yeah, they might be having, because I'm very used to PyCharm. I just opened it up and used it, but feel free to use any editor of your choice. In fact, what we can do is in our actual course, when we go ahead and deeper, we can discuss about different IDs also. What each one feels about their own favorite ID. Like, I am very much familiar with, in my company, I use PyCharm Professional. So I use PyCharm Community here. If you want to explain, if you want to discuss about some features in IntelliJ with Python support, we can as well use that. And remember, Visual Studio Code is even more powerful. It has better features. It is free, but Visual Studio Code can be a bit cryptic at times. So that's why I preferred using PyCharm. So that's it. Any more questions that you people have? Anything that is not understood? Anything that you want me to touch up more? Feel free.
I would like to find out what things we need to install before the classes come in.
Yes. So I'll just open this. Yeah. So first thing is you need to install Python 3.8 plus, and that is easily available. In fact, I have Python 3.13. If you see in my PyCharm, I think I was using Yeah, I'm using Python 3.13. So you can install that. It will be very easy. It's just if you are using Windows, then just go to the website python.org, download it and double click on the MSI. It will install your things. And then once Python is installed, you can just install PyTest automatically. I was going to show this to you in the actual course, but let me just briefly touch base. So let's say you're here. Okay, let's say I'm in test calculator and I remove this line. Okay, and PyTest is not installed. You're adding a test case, PyTest is not installed, and you write this import PyTest. Then PyTest is not installed. It will underline this with a red color. Okay, and when it underlines with the red color, you just right click and say install. It will install it automatically. You don't have to do anything else. That's the power of these IDEs. It can help you do a lot of boilerplate things easily. That is second point. And then you need to know a bit of Python, but that I'll also explain to you how to write Python functions and everything. So that's not a very difficult task. We'll spend some time, we'll dwell upon some Python syntaxes as well in the course. So essentially, to answer your question, you need Python 3.13 and PyTest to be installed. Those are the only two softwares that you need to install. Okay.
Those can be installed from marketplace as well, extensions.
You mean in Visual Studio Code that you're saying?
Yeah, any IDE, IntelliJ, Visual Studio, and
Yeah. You can install from marketplace as well. There are a lot of techniques and ways to get these softwares. I mean, there is no right and wrong. We whatever is there is also something called as PIP, that is pip installer. Then there is Conda for Python. So there are different environments and available package managers which you can utilize to install these softwares. It's quite easy. We'll develop on those. Don't worry. I'll prepare a list of different IDs versus different extensions versus different installers and display in a single page to you when the time comes.
What
would
is the
this
course
also have?
duration and fees?
Sorry, two guys asked asked at the same time. Manan, can you go ahead, please?
What is the course duration and fee structure?
This question can be better answered by Mr. Kumar. I can share his number with you on the group, on the WhatsApp group. Maybe he can answer your question better, Manan. I'm not very qualified to answer that in this forum. So I'll take your question and I'll ask you to just see the group for Kumar's phone number and talk to Kumar for that.
How about the marketing? Do you guys do marketing after the course?
Marketing in the sense, I didn't get you.
Profile marketing?
She means job replacement, I guess.
Oh, yeah.
Yes.
Okay, so that I think because my scope only relates to the instruction part of the PyTest part. Maybe you can talk to the training institute for that, for more on that placement and profile creation parts of it. Like like the Isha Training Institute people. Again, Kumar can answer that question. I'll just stop the recording because we almost reached the end. Yeah.